Welcome to the next episode of Stack Dive. Today we're going to be looking at FastAPI and creating FastAPI endpoints that tap into a PostgreSQL database. So FastAPI is a Python web framework that's built on Starlet, which is basically the gubbins that powers it, and Pydantic, which does data serialization and deserialization, which basically means making sure the information you expect to come in is actually what's coming in. And it's maybe like tied with Flask for being the most loved Python web framework. It's my favorite because it is asynchronous, which means it can handle more than one request coming in at the same time. So if it's waiting on if someone says, oh, give me X information, and then the server has to go and send a request out somewhere else on the internet, and therefore it's just waiting for something else to give back some information, it can do something else whilst it waits, and this makes it a lot faster. Yeah. So what I'm looking at today is I've already got a FastAPI application set up for a site I'm building called OpenEngine, which is going to be an open source search engine. And this is the backend API that interacts with Postgres and another database called Quadrant, and also runs crawls to crawl information so that it can be served through the search engine. So what I'm looking at today is these things called CDLs. So you look at this. This is the part of the setup we're looking at. So I've got PostgreSQL, and I've got inside of it these things called seed URLs, and these are the initial URLs that I'm going to crawl to produce my index, which can then be searched. And these CDLs get passed to a crawler, to an URL queue, and the crawler pulls URLs from the URL queue and processes them. Well, not processes them, but reads them, gets the information, finds new URLs to crawl, and then they get processed and information gets added to Quadrant, and Postgres is updated with extra information about the URL as well. Okay. So let's get started. These. Oh, maybe I don't know. So this is the first one we're going to be looking at. This is update seed URL, and this is a function that will update a seed URL with new information. And so you can see here I've got this type that I'm importing. Hello. I've got this type that I'm importing, and this means that when information comes into this endpoint, so this is how you set up an endpoint in FastAPI, by the way. So you can see at the top here, I'm pulling in this. So I've got my FastAPI. So I pull in FastAPI. Here we go. FastAPI, import FastAPI. This is my this is my entry point to FastAPI. And I'm giving it a lifespan parameter, which is just information about what I want it to do on startup. And then you can also have yield in here, and then write what you want to happen on shutdown. And it gets put into this little object, this variable called app, and then I can use app to write my endpoints. So you can see I've got, for example, @app.post login. So this is the type of HTTP, what do you call it? Method, the HTTP method. You can have like get, post, put, delete, update, etc. And so I've got this here. So for example, post add CDL. This is how I add a CDL to my storage, to my Postgres backend. And for this one, I'm going to have post. So if you make a post to update CDL and you send in an URL information with URL update data, then I'm able to do something with that. Yeah, then I'm able to take that information, pass it through to a function, and have the function change the PostgreSQL database. At the moment, I've got all of my functions for the database stored in storage. So let's set up a test first, because I like to do all of this using test-driven development. And to do test-driven development, yeah, we have pytest.amark, async.io. But all of this was generated automatically by a tool called Supermaven, which is a really good tool for code completion. It's a lot better than Copilot in my opinion. So in this test, we're going to do, what am I going to do here? Correctly update CDL in the database when a valid token is provided. So at this whole thing, this API is protected by JSON web tokens. So there's another endpoint here, admin login, that checks credentials, and if they're correct, provides a access token. And this access token can be stored by the client and then passed into the other endpoints. So this is a form of authentication. And this is how it works in FastAPI. You can say that your Postgres, oh, sorry, not this one, your token depends on this OAuth 2 scheme thing here. And if we go to where this is defined, this is some standard class that FastAPI provides you with. And this class will look inside of the request that's sent to your API endpoint, pull out the authorization header, and return to you the JSON web token. And then you can check inside of here. So the first thing you would do is check the token basically. But let's not do that just yet. Let's set up the test first. So, yeah, so this is another good thing. So this is how you override functions in FastAPI. So FastAPI, I've got this depends statement, which says to get the Postgres client, I'm depending on get Postgres client. Now this is a function up here, and this return value is what gets passed to this parameter, to Postgres client. Now this makes it possible for me to use during testing to do app.dependency overrides, and then I can choose some function, in this case get Postgres client, and I can return another function. That function will be called instead during the test. And so I've just got a lambda, which is an anonymous function that returns empty Postgres client, and that's all I need. Okay, and this is the other thing that you have to do for testing with FastAPI when it's asynchronous. You need to use async with async client. Whoops, and you can see I've imported that from HTTPX. HTTPX is the asynchronous test server that FastAPI uses, or maybe even Starlet uses. Oh, come on. Do it for me. There we go. And you can set it up like this. So I can say I want to have an async client with this information, where this is, I can't remember fully exactly what it's doing, but it's basically wrapping my application. So whatever the main.py endpoints are, it wraps it and makes it easier for me to query. So add a CDL to the database, ac.post add CDL. This is just me adding a CDL. And we can check and message CDL added successfully. Yeah. I've already checked all of that. And then, yeah, so it's already given me the update the CDL part. So this is an asynchronous web client, which means that when I do ac.post, this is me sending a post request to this endpoint, add CDL. The endpoint's been taken from app.app, so it's just going to come in here and say, I want this one, right? And yeah, so then uses this authorization header that has a valid token. And I'm also importing this, so maybe I should explain this as well. These are called fixtures that I'm pulling in here during testing. And if you come to conf test, you can see them. You don't have to set them up in conf test. You can set them up in normal test files. But fixtures are a part of PyTest where, say, for example, you find yourself running hundreds of tests, but there's setup that you do for each test and you constantly do it. It's better not to repeat it. It's better to pull that setup out into its own function. And that's what fixtures are in PyTest. And you can even scope them. So, for example, in this case, this fixture is scoped by function, which means every single time I run a new test, if I'm using this fixture, it will reinitialize. And so for empty Postgres client, this is just me creating a Postgres client using async PG, which is an asynchronous Postgres connector, and creating all the tables that I need, yielding the client, and then cleaning them up once I'm finished. And similarly for valid token, that's probably at the bottom. This is just me creating a token that I know will be valid because it's got a time delta of 300 minutes in the future. I can use a secret key, some algorithm, some data. I can encode it, I return it, and that gives me access to the API endpoints. Oh, we have a viewer. Oh, Snowchild. Hello. Okay. So now coming back to this, I am, yeah, so I'm giving this Postgres client to my application when it gets the Postgres client, and then the information that I've put in conf test, the tables and stuff that I stored in there will be used inside of here. So in this Postgres client. And this is what allows me to run tests. This is what allows me to mock a real database. So we've got message CDL added successfully, and now you want to update the CDL. So we're doing the same thing. We're using our asynchronous client, posting to the update CDL, and then giving it my authorization token and swapping the old URL for the new URL. So I'm going to say, let's call it Snowchild, snowchild.com. Right, check the URL was updated in the database. Results await. Empty Postgres client.fetch. You can sort of see how fast the Supermaven Copilot style thing is. So we got results equals await, empty Postgres client.fetch, select star from CDLs, assert length results equals 1. Yep. Okay, nice. So now I'm going to run this test. PyTest, tests, app tests, test main.py. We want test date CDL. So in case you haven't seen it before, this is how you focus on one test at a time in PyTest. Token is valid, blah blah blah, failed. Yep, fine. Now we expect it to fail because I haven't actually done anything inside of here. Okay, so first thing to check is this is standard. You'll see across all of my endpoints that use tokens. Yeah, I haven't thought too deeply about this. I think Supermaven gave this to me initially, and I looked at it, I ran some tests, it worked. I was fine with it. Right, update the LN database. So check if the credentials are correct. Update the LN database. Okay, so again, this is just me setting up the connection to the CDL. Yeah, so this first part, I check if the access token is valid. Let me just see. Yep. Arguably, actually, this should be its own function, shouldn't it? It's just repetitive. I'll look into this later. Repetitive, but oh well. Yeah, so now I've got what I feel like should happen. I've got storage.update CDL, earl.old earl.earl, Postgres client, and that should change the earl and make the test work. So if I try and run this now, it failed. Why? Because storage doesn't have the correct function. So this is the next thing to do. We need an asynchronous function, async def. Check that's actually async. Is async def update seedo. And we need old L string, new L string, DB client. Actually, do I want DB client? I think I'd rather that Postgres client. just for consistency, even though I haven't done that in some of the others, but oh well. The old L to update, the new L to update, async pg.connection, yeah. True if the L was updated to false otherwise. Nice. So to new L. Except exception is Z, return false. Nice. So I'll talk you through this as well. So this is an asynchronous function in Python, which means, as I said initially at the start, it doesn't block the event loop. It doesn't block other things from happening. It runs, and then if it reaches something like an await, if it gets to this await, because this requires going to a different piece of software on the same computer, on the same machine, but not Python, it will not pause the execution of everything else that Python is doing. It will just pause this one bit and start running something else, and then when this is complete, it will come back to this function and carry on. And what I'm doing here is I'm using my Postgres client to execute this SQL statement, update cdels, so this is the table called cdels, set Earl equal to the new Earl, where the Earl is equal to old Earl. This is probably slightly slow, probably a slightly slow operation in Postgres compared to some other stuff, because you're having to run a comparison on every item in the table. However, because the cdels is probably never going to be much more than 10,000, 15,000, and the changes that you make are going to be small as well, it doesn't really matter. It will be an over optimization to do it another way, and this makes a lot of sense, so it's better to do it this way. The reason we've got this star attribute, and we've got the attributes defined up here, is because when this executes the command, it takes new Earl and puts it in the position $1, and old Earl goes in position $2. And whilst it's doing this, it checks for SQL injection. It checks that someone isn't trying to get all the information out of your database by injecting some SQL in, which could basically reveal information. But I suppose realistically, it wouldn't matter that much because you're the admin, so you would have access to it all anyway. But anyway, okay, failed to update Earl with error E, blah, blah, blah. So that should work. Let's create a test for that in storage as well. Whilst we're here, pytest.mark async.io, yep. Add the L database, update the L database, get the resource from the database. Was it added correctly? Snowchild, he's left us now. Long live Snowchild. Earl equals https example.com, add the L to the database. Earl, empty Postgres client. Yeah, that should be fine. Update the L in the database. Earl to that, empty Postgres client, nice. Get the resource from the database. Select star from cdel. Length should be 1. The ID should be 1. And the thing should be snowchild.com. So if we change this now, rather than go to test main, let's go to test storage.py. And test update. Oh, is it the same thing? Hey, one passed. Perfect. So if I go back up to test main, test update cdel. That passes as well now, and it's normally best practice just to pytest everything and make sure it's all still working. $30 items collected. Test gather. One fail, but that always fails. Deliberately as well, because I've just gotten a cert false in there. Why am I deliberately making that fail? Test get top matches. I'm not sure, maybe I just didn't finish it. Anyway. Okay. So that is very simply how you can create a client. I mean, this is really how you do it. Base Postgres details. Start ephemeral Postgres. Stop ephemeral Postgres. I could show you this as well. So basically you start a temp directory. Start a data directory inside that temp directory. Run the initdbd whatever process for Postgres. This is a like command line command basically. Actually, I'm not sure fully what this. I think this basically means just chuck all the output to nothing. So we don't care what the output is. Just throw it into the ether. Delete it. This is the port that we want to run on, and then we do subprocess.run. Run all this information. Do all this. This starts the Postgres. We've got our database initialized here. We pass in the data directory. We pass in the port. Run all of that. Error and out go to nothing, and then we return the temp directory and the port, and we need these things. Later on, we need the temp directory to be cleaned up, and we need it to kill Postgres. And the port we need, so that when I come into conf test here, I can get the port, I can yield the port, and use that here. So in base Postgres details, this is a fixture that's scoped to the session. So it's scoped to the testing session. When I run PyTest, this function is scoped to the testing session. I pass base Postgres details into empty Postgres client, get the port, connect using my asynchronous Postgres connector. This produces the ephemeral database for me, so like the fake empty database. I add all my tables, I give back the client, which allows people to interact with my fake database, and I clean it all up. And this is how you can test Postgres on the back end without having to actually have a real database running, or something like a Docker container or something like that. And then normal testing is just PyTest testing, which hopefully you're familiar with. Drop a comment if you're not. I can go through it. So next one, same sort of process. We've got update CDL, start crawl, stop crawl. I'll do all these later, and then I want get CDLs, get searchable URLs, get potential URLs. So get CDLs. We are going to do the first thing as per usual. We want to check that token if auth.check access token return await storage. That's right. HTTP exception. I don't really want to do it that way. I'd rather do it the other way around. Not. Ta-da! Okay. That's our main. Let's go to test main. Oh, maybe I should. Okay, well, just to be more thorough, I'm just going to copy this and I'm going to do another test. So test update CDL valid token. Actually, we need that valid token, don't we? I still need the valid token because I still need to token. So let's just give it some nonsense. There. So that should still be one, but it should be example.com. Update CDL token. Cool. There we go. Passed. Lovely. Now the next one. Well, I suppose there is also. What if you did the wrong Earl? So what, I suppose. Look at this. This is so good. So check that the getCDL endpoint correctly returns a list of CDLs from the database. App.dependency overrides get Postgres client, blah, blah, blah. Async with async client, etc., etc. Add a CDL to the database. Yes. Let's add a couple of these. To add equals https example.com, https snowchart.com. Who else is there? Casey? Fine. Well, then let's to add. Get rid of that. CDLs to the database. Nice. Okay. Then we want to do that. Get the thing. Assert. Yep. That. Yeah. Oh. Don't know that it would be that. Anyway, let's try running that. Test. Get CDLs. No! No attribute, what? Again, that is as expected. And so, let's go to test storage. We're trying to do test-driven development here. And I'm going to do at pytest.mark async IO async def test get CDLs. Check that the get CDLs function correctly returns a list of CDLs from the database. Earl example. Oh no. Da, da, da. Is it slightly disconcerting when they kind of just happens like this? It can just do it all for you. You're like, oh, No, it's great in a way. I love it. The CDELs, the database, assert a wait, st.add CDELs. Yep. Yeah, okay, I think that should be fine. Let's do test storage.py. So you can sort of see here the way this works. The flow is set up a test in test main for something that you want to happen, like some information that you want to get out. Turn that test, run that test. When it fails, and it will fail, go into the FastAPI main module, write the endpoint, and connect it to some fake backend code that you want to run. That will fail as well. Write a test for the backend code module. That will fail as well. Write the code to make the backend test pass, and that should pass the front end test as well. And there you have it. And as it happens, it's really not too bad. Like, it ends up being fairly simple to write these little API endpoints. So for this, in fact, as it happens, apparently, get a list of CDELs from the database, a list of CDELs, get the CDELs from the database, results equals await, get this, convert the results to a list of ERLs, ERL result 1, return ERLs. Ah, there we go. So it did all that for me. And now if I run this, it passed. Great. And what happens if I do test storage, test main.py? That one might not work. But you can sort of, one of the reasons Supermaven is so good at this is because this kind of connection. So FastAPI, so a request comes in, FastAPI sends it to Postgres, Postgres sends back information, and FastAPI sends it back. It's so common that it's seen a lot of it, and it can produce results for you really quickly. So it failed because of what? Return await storage .get CDELs Postgres client. Okay. That's a HTML response. What does Postgres return? What does FastAPI return by default? Okay, so for the first time in forever, for the first time in forever. Bam. Right, let's see. We have a viewer. Hello. By default, what does FastAPI? Does a FastAPI endpoint return? So here's another thing I like to do. I like to write flashcards for things I'm looking at. So this is a great example of a flashcard moment. Oh, what's going on here? Oh, because it's in edit mode. see. JSON object return. Hello, viewer. Can I help you? What made you click on the video? Okay, so that should return a JSON response. Returns a JSON response. So what went wrong? What went wrong? Failed. Response validator. 3 validation errors. Let's get CDOS. Type. Oh, because it wants a list of these. Oh, I see. I see. So it wants me to turn a bunch of CDLs. Suppose I could do that. So if I say Earl is result 1. Oh yeah, this isn't JavaScript. And now if I run this test, let's see. Still fails. Assertion error, assert. Aha! We're through. So I've broken through the validation, whatever. Another thing I quite like to do is I quite like to write notes. So underneath my stream plan, if you have an endpoint defined thusly, you try and return something that isn't in, that doesn't fit response models type, you will get validation errors. Correct this. They're returning things. Format. Issue. Fix found. Nice. Okay. So now if I come to test main and I say, instead of saying this should be equal to Earls to add, I can say response is okay. JSON equals. Huh? Yeah. Else into the expected JSON format. Cool. And now, ta-da! Lovely. So that is the get CDARS one complete. Let's do get searchable URLs. Actually, whilst I'm here, get searchable URLs. Is that a good name? Get all the searchable URLs. There are URLs that have been crawled and processed. Get searched URLs. Searched URLs. Get all URLs. Whatever. Okay. Test main. And I shall repeat the process. PyTest, start mark, async IO, do this, valid, empty Postgres client, check that the getCDARS endpoint refused to return a list of... Nope, don't care about that. Test get searchable URLs. Yep. Empty Postgres client. What did I get from populated Postgres? Okay, so this, I'll probably just use this one. I'll just use populated Postgres because it doesn't contain the CDALs, but it's already got searchable URLs in it. So you can see if I come in here in the populated client, I create the resources table, which is where I'm storing URLs and potentially in the future YouTube videos and stuff like that. And I've put in already an URL to some chap, Casey Hammere, who I happen to think is interesting, think his site's interesting. So I won't have to do all of that in here. It's sort of already been done. Okay. In that case, I was with sync client. So get the searchable URLs. Response to IO get searchable URLs. Check the response is okay. Don't think it will have all that information. So let's just say I'm only going to get. No, I'm not just going to get that though. So going to get data Search files list. Search 2 1. Down. Let's also check that last visited is less than date timed on now. Wait. Do the same thing here. Cool. Let's try that. What? Oh yeah. This should fail. Doo-doo-doo. Oh, there's an error. Where? Error at setup. Syntax error. Wait, what? Is this really not used? Is this really used nowhere? Oh shit. That's the only place it's used. Okay. So the issue here is I'm using when I first set up this fixture, this PyTest fixture, I was using a different connector, a different client, and that one used this %s for the different attributes to be added, whereas the new one I'm using uses $sign and a number for the position in the attributes list. And so if I just change that to that and run that again, this should now fail on something else. Server expects 5 arguments for this query. 1 was passed. Oh yeah. Okay. I don't need to include them. Async client object does not support the context manager protocol. Oh, right. So this would just be me doing this wrong. Async with. Validation errors. There we go. That's more what we wanted to see. So test get searchable errors. So if not, auth check access token raise exception, blah blah blah. Same gubbins we've seen before, which should probably be its own function. Return await storage.get searchable errors. Will this run? It won't, but may as well try it and see. Has no attribute to do this. Ah, I see. Okay. In that case, then, let me write a function, a test, to see if I can make this work. Check that the get searchable errors function correctly returns a list of CDLs. Errors to add. Yeah, I'm fine with that. Add the CDLs for the database. Add CDL. Get the searchable errors. No, that's not. That is not correct. In fact, let's see. What do I have here? Test log resource. Test store to embeddings. Test store embedding. I think it's log resource. Let's try this. Probably just define the time. Outside of here, the time assert.await log resource earl. No. Resource empty Postgres client. Probably. Yep. Get the searchable errors. Let's say check the errors are correct. Assert the length errors. Results no. So then we say maybe let's just print it first. Oh, let's print it first. Print the results. And this will fail, and this print statement will tell us what format to expect. Okay, let's run that then. Oh. Agreeably, it looks the same. Get searchable errors. Oh, yeah. So you've still got no searchable errors, but everything else ran fine. So def get searchable errors Postgres client list stra, or do I actually want to be returning data types? Do I actually want to be returning something else? What do I have a main to return? It's saying I'm going to return a CDL, but no. I should call this a crawler. First visited, last visited, all visit external links. Yep, that's good. Date, time, import date, time. Hopefully that's fine. So something that's always quite funny is when you're defining these models, these data types that you want to add, it's quite funny when you give it a name like crawled Earl or something like that. And that's just something that's come in my head. I think that makes sense at the time. And if this software ended up being used by hundreds of thousands of people, even if that name ended up being terrible and it just didn't make any sense, it would just stick. It's so funny thinking that can just happen. And then people will think there's like a really good reason for it. People could end up defending it or something, even though it's just a terrible name. And arguably, yeah, I mean, maybe, yeah, you could argue it is a pretty crap name. Crawled Earl. And then I'm sort of looking at this and going, well, why have I called it searchable Earls if I'm returning crawled Earls? But calling it a searchable Earl, it doesn't really make any sense. It is more of a crawled Earl, so should this be get crawled Earls? Yes, it should be. I don't care. I'll change it all. Oh no, because no, it has to be searchable. It has to be searchable. Because any Earl that's crawled, is it what's called searchable Earl? I suppose. Yeah, it kind of is. Yeah. Yeah, okay. Let's change this. Get crawled Earls. And again, this is one of the beauties of testing and stuff, is that when you do stuff like this, it's very easy to see when things have failed. You can make these name changes and stuff because you've got tests set up defining how things should work. And so if you make a change and it affects something else later on, it's very easy to see. Get searchable Earls next. Get crawled Earls. Storage. Get crawled Earls. Nice. Postgres.fetch select star from resources where all visits is greater than 0. Doing that bit. Need where all visits is greater than 0. No. Nice. Okay. Let's see what that gives me. Test get change this. Let's see now if I do result in results. Result. See if it's got a to-dict method. Okay, so if I say that this is actually a list order, things are available. Dict. Use model dump. Okay, nice. Nice. Well, I suppose I don't actually need to do that, do I? I could just do... Yeah. This enumerate thing just gives me an index to work with. Okay. See if that works. And it does. And then let's see if... See if my main function now works. Oh! 3 instances of strat and datetime.datetime. Oh, crap. So it's come back as a string. It's come back as a string, really. Oh, I spelled it wrong. Same thing. Hmm? No. Pass? If that will work. try this. See if that works. Oh, doesn't like that for some reason. Cannot import. Oh. Try again. Last visited. Okay, so it did work. Nice. So that we can copy this. What else? Last visited. Bam, bam, bam. Get in. Come on. Simple. Oh, there we go. That is that. That is another endpoint done. And then the final one is get potential URLs. I don't necessarily need to do this right now, do I? So the point of this one is to pick up. What did I call? I've got my resources table, but I've also got admins table. I've got my CDLs table. So yeah, so we've got the resources table. Maybe I should have called it get resources, to be fair. Let's do potential as SQL. So we want to do that. And we want an URL. Don't care about first visited. First seen. Care about last seen. Time seen. Well, so this is just me editing the conf test slightly, this fixture with the empty Postgres client, so that I can use it for potential URLs SQL, for testing that basically. Okay, let's run a PyTest on everything, and I will come back to main or test main. Let's think about what to do here. So we got async. Oh, test.mark async IA. Valid token populated Postgres client. No thanks. Empty Postgres client. Checks. Database. I don't really need to post a potential URL. I need to get them. So really, I do also want storage to do that for me too. So if I just come to storage, test storage, and we do the part test mark. Okay. Is that being nice to me? Let's get potential test. Okay. Get rid of all of that. Yep. So this is just going to add an URL called example.com and then add the time seen, etc. And then what I want to do is add another one again and just see that it increments and says, oh, I've seen this URL now this many times, etc. So if I do, I don't want to check the URLs out to the database. I'm going to do potential URL. Check this seen column. Okay. So, oh, 2 failed. Undefined table error. Aha. Never. Wait, client.execute. Save that. This should all pass. This is why you got to run the PyTest at the end. Test auth error. What? Oh, for goodness sake. Let it run. Right. There we go. That's more like it. Sure, this will fail. Test async. Def get cdels update. Def add potential alpha seen db client pool adds a new potential. Client. No. Then I'm going to put a index on the URL column in Postgres. So actually, what I'm about to do here isn't so bad. Turns bool. Otherwise, create a tuple of the resources. Yep. Try awin db client 1, 2, 3 attributes. Exception as e print failed to add with error e. True. Refailed. Test get cdels. Format. Sorry, I'm just correcting a test here now. That should work. Like that. Actually, no. Rather than do that. Right. PyTest tests app tests test storage.py. There we go. Scene select start from blah blah blah. Right. Failed. Test app potential. So not true. Which one? Ah, that was an error. Where's my failure then? So, attributes. Ah, so it failed because... Yeah, I see. Okay. Actually, that's a very good point. Done this before where I checked if the error was valid. Enough times already. Should probably put it in a utility function. So this just basically checks for the URL scheme. If I come to just add that down here. Here, should I say? Don't know if we need all of that. Nice. Otherwise, okay. Bam. Let's give it a go. No module named utility. App.core.utility. Come on. Okay. So test at potential. Oh. And that again, what was it saying? Assertion error. Assert. Not await. Assert not true. Some sort of exception, are we? It's fine to me. Ask, because that's it. Assert not. Test storage. No. There we go. So just because I was negating the true statement that was being returned. Yes! Okay. So now I've got that. I should now be able to test get potential URLs. So what do I want to do here? So if I say dummy potential. Oh. Snowchart.com, datetime.now, and 1. I do insert into potential else. Oh, get PostgreSQL client as a C, get the potential URLs. So, yep, check. What would it be? A scene. Yeah, time scene. To 1. Okay, don't care about having that. Have I got print statement somewhere that's upsetting it? Yeah. Cool. Okay. This should be the final one now. So back to the way this works. Test get potential URLs. Going to start off in the main testing file. This is going to fail. Test main, test out. And it's going to fail because it didn't return these things. Oh yeah, I also need to add a data type. So I've got crawled Earl, seed Earl, Earl update data, and I've got a potential Earl base model Earls first seen time seen. Nice. We'll import that into main. That's the first thing. Potential Earl. And then when it gets returned, it will be a potential Earl. Filter algorithms, and it failed, not just for that reason. So first things first, if not check auth, blah, 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 do all that stuff. Otherwise, return storage.get potential L's Postgres client. And we can run that now, and that will still fail. And we can come here to, oh yeah, let's do the test storage first. Yeah. Async def get potential L's, check the get potential, returns list potential L's from the database. No, don't want that. Time, timed on now. Sure, for Earl and L's to add, create a resource. No. Trying to be too clever now. St dot add potential L date time dot now. Get the potential L's. Database. List of potential. Oh. Right. Okay. So now we can do it in storage.py. Oh, there is an issue. What is this issue? Async line 403 in storage. Ah, right. Yeah, well, it's not going to run, is it? Because I don't even have the function in there. Parameters, the Postgres client. To access the list of potential. Bam. Get the potential L's from database. Select star from potential L's. Earl is potential L. Earl result 1. Ooh, yeah, sure. Result and results. Return Earls. Bada bing, bada boom, baby. Now, if I do my test on main, yes. If I PyTest everything, I should have one failure. One failure and it's a success. Come on. All right then. So the last thing to do is to put this all onto lazy git. So this is basically, at this point, I have finished the Postgres stuff. In fact, do you need to see me do this? Possibly not. Okay, thank you. So that is how you can create FastAPI endpoints for PostgreSQL. If you use Supermaven, I'm using the free version, so you can see even the free version is amazing. That is how fast you can create them and how you can set up a testing backend to create a temporary directory that you store a Postgres database data directory in, and then run a Postgres sub-process from and store information in there. And do all that without having to run like a Docker container or anything like that, and make your tests really nice and fast and get things done. Get things tested well quickly. I hope that's been useful. If you've got any comments or questions, chuck them down below, and I'll see you in the next one, which will be me creating the API endpoints for starting a crawl and stopping a crawl and pausing a crawl. So chat to you in a bit. Bye. And stopping a crawl and pausing a crawl. So chat to you in a bit. Bye.